Well, hello guys, in this video I will try to cover some examples, around 5 or 6 examples for mu test, comparison test and limit test. So let's start with the mu test, which is too much important and too much hard also. So first of all, as you know, for testing that the given integral is converging or not, we have to use mu test or something like that. Limit x is tending to infinity, x to the power mu fx is equals to lambda, where lambda not equals to 0 for mu greater than 1. If this condition, wait a moment, if this condition will be valid, it then it is called, the integration will converge or something like that. Otherwise the integration will not converge. Like if we are saying that the lambda is equals to uh, plus minus infinity, sorry for a mistake, plus minus infinity and lambda not equals to 0 and mu less than equals to 1. If this will happen, then will not converge, will not, and will. Hopefully you can understand, this is the fundamental law, but the problem is finding mu. So let's talk about an example. So first of all, we will see some kind of algebraic functions. In that case, we are talking about algebraic functions. Let's say this is the integration from 0 to infinity. You can solve it easily using any kind of substitution or something like that, but our goal is to test the convergency of this integral without solving the integral. So in that case, we will use mu test. How? Just look at the denominator and look at the highest power of the denominator, which is 2. Mu is equals to highest power of the denominator, I mean not denominator, I mean highest power of x at the denominator minus highest power of x at the numerator, which is 3/2. Now mu is half. This is the process, but this will be applicable for only this kind of functions like algebraic functions, where basically this function is basically the ratio of two algebraic functions like polynomials. Hopefully you can understand. In that case, mu is half. We have to find out limit x is tending to infinity, x to the power mu fx. Now mu is basically half, and half less than 1. We have to, first of all, for testing the convergency, the first rule is mu greater than 1 and lambda is a constant, not equals to plus minus infinity and not equals to 0. Be careful about that. Be careful about it. You just need to remember these two things. If mu greater than 1, then it will converge, and also lambda is not equals to plus minus infinity or not equals to 0, then it will not equals to 0. Sorry, this is not a correct sorry for a mistake. Mu, if first of all you have to talk about mu, if mu is greater than 1, then it's okay. Then we have to check the lambda. Maybe the lambda is plus minus infinity. Hopefully it is visible now. Plus minus infinity, then it will converge. Otherwise it will diverge. Just you need to remember, first mu should be greater than 1 and lambda should not be equals to plus minus infinity. It may be 0, doesn't matter. In that case, we can easily see mu is less than 1, right? Because mu is half. So it will diverge simply. But we have to check the lambda for more properly. For checking the second condition, right? Basically more surety, you can say also. In that case, this is half and fx is this by 3x square plus 5 limit x is tending to infinity. Now this is basically 3/2 plus half, which is 4/2, which is 2. So this is x square. This is, we are taking common x square from the denominator. We will get 3 plus 5 by x square, right? Hopefully it is visible. Now limit x is tending to infinity. You can use LH rule also, it depends on your mood. I am using this, however it depends on my mood. And if we are putting infinity, then you will get 1 by 3 plus 5 by infinity, which is nothing, this is nothing but 0. So 1 by 3 plus 0, which is 1 by 3, and 1 by 3 is not equals to infinity, or not equals to minus infinity, not equals to 0 even. So in that case, what is happening, still it is not converging, because because of mu less than 1. So you have to check two conditions. If the first condition will, let's say, will be verified, but the second condition is not, then in that case it will not diverge. Sorry for a moment, it will not converge. It will not converge. If basically, if one of the condition will not be satisfied, then it will not converge. Simply, you have to remember these two conditions. Hopefully you can understand. First condition is mu greater than 1, and the second condition is lambda should be not equals to plus minus infinity. One of the condition, if one of the condition will not be validated, then, or will not be let's say maintained, in that case they like the integral will not converge. Basically, this is very easy to understand, hopefully. Now let's talk about another example, so that you can relate with the question properly, I mean relate with the test properly. Now basically, let's say we are dealing with this question, let's say x square by a square plus x square whole to the power square dx 0 to infinity. Now in that question, you can see the denominator, the highest part of the denominator will be x to the power 4. If we are breaking this term into binomial, then we will see x to the power 4 is the 4 is the highest degree, or the you can say highest power of x at the denominator, minus the highest power of the x at the numerator, which is 2. So mu is nothing but 2. So in that case, you can see mu is greater than 1, right? 2, because 2 is greater than 1, right? So it will definitely converge. But let us talk about the second condition. If the second condition will not be maintained, in that case it will not converge, it will diverge. So for second condition, for checking the second condition, we have to take this limit x is tending to infinity. Mu is 2, so we are taking x square into x square by a square plus x square whole square. Now basically we are taking common x square from the denominator, this is x to the power 4, and if we are taking common x square, it will become x to the power 4, this is a square plus a square by x square, plus 1 whole square, right? This will be cancelled out. X is tending towards what I'm saying, x is tending to infinity. Now this is 1, this is a by infinity, which is 0, so 1 square, which is 1, so answer is 1. I mean lambda is 1, so lambda is not equals to plus minus infinity, not 8, it's infinity. So the second condition is also maintained. That means we can say this integration will converge. Hopefully you can understand. This is the process, and this process, I mean we are talking about mu, so this process will be valid for only this process will valid only for this kind of question, where we will see the ratio of two polynomials or something like that. But the actual process is something different. We have to choose mu something like that. The limit, let's say this is the limit will exist. This is the process. Actually, we have to choose mu, and we have to be careful. Okay, we have to choose mu in the way, so that the integration, not the integration, the limit will exist, or something like that. So let's talk about another example of mu test. Now basically you can see, this is for your information, this is not gamma function, because there is no 0, there is 1. Okay, so be careful about that. However, we have to check the convergency of or divergency using the mu test. So how we can test? In that case, we can't see any kind of power in the denominator or numerator. However, and specifically we are talking about in that case we can see e to the power minus x, which is an exponential function, right? So how we can deal with that? In that case, we have to take mu, but be careful. we have to choose mu in that way so that the limit will exist, x is tending to infinity, limit will exist. So be careful about that, the limit will exist. So we have to choose mu, be careful, the limit will exist means we have to check the convergency. So we are using a simple rule, which is, as we know, if mu greater than 1, then the integral will converge, and also lambda not equals to plus minus infinity, then the integral will converge. So you have to take a value which is greater than 1, and if the integral will converge, then this will also be maintained. Like if I am saying lambda is 2, which is greater than 1, then the integral, the answer of this limit should not be equals to this. So basically we have to choose a value which is greater than 1 for checking the convergency. If this condition will not be maintained, then the integral will diverge. Right, then the integral will diverge. Simple. Hopefully you can understand. Let's say we are taking, let's talk about this example. We are taking mu greater than 1. Let's say 2, we are taking 2, mu is equals to 2. Just assume it. So x square fx is e to the power minus x to the power n, limit x is tending to infinity. Now this is x to the power n plus 2 by e to the power x. Right, limit x is tending to infinity. Now you can see this is e to the power x. If we are using LH rule, simple LH rule, use the LH rule. However, now you can see this is x to the power n plus 1 into n plus 2. Right, this will happen. Again, if we are using LH rule, because we can see this is basically nothing but infinite by infinite format, right? Infinity by infinity format. This is n plus 2 into n plus 1 into x to the power n into e to the power x. And if we are using LH rule continuously, or you can say n times, sorry, not n times, basically n plus 2 times, then we will get e to the power x at the denominator, and we will get a constant which is basically, let's say, k. And if we are doing again LH, I mean we are using sorry for a mistake, we will get a constant, right? We will not use LH rule now. This is basically constant by e to the power x, and x is tending to infinity. So basically constant by e to the power infinity, which is basically k by infinity, and something by infinity is 0 always, because infinity is a very large number, right? So we can say this limit will be let's say 0. This limit will be tending to 0. Okay, fine. So now you can say as lambda is tending to 0 and not equals to plus minus infinity, so this integral, I mean this limit, I mean sorry, this integral, this integral will converge. Now I am giving another example so that you can relate with that question more properly. Wait a moment. Now you can see this is an improper integral. Now we have to use the mu test for solving that question, not solving, I mean for testing the convergency of that question, of that integral basically. Now basically you have to solve the limit x is tending to infinity, x to the power mu fx. Now as I have told you that we have to take mu which is greater than 1, and basically we are let's say assuming the first condition is correct, and we are satisfying the second condition also, where lambda is not equals to plus minus infinity. Hopefully you can understand this portion, right? We are assuming the first let's say first condition is correct, and on the basis of the first condition you have to prove that the second condition is also correct. If the second condition is not correct, then the integral will not converge. Simple. So in that case we have to take mu which is greater than 1. Let's say we can take anything. Let's say mu is 3, just assume it. So x to the power 3 into log x by x square, limit x tending to infinity. Now this is x, this is log 1 by x, limit x is tending to infinity. Now you can see here basically this is x to the power minus 1. Now you can see we can't solve this properly. Basically, like, this will be log of infinity. Log of infinity means infinity, and this is 1 by x, which is 1 by infinity, which is 0. So infinity by 0, so it is tending to infinity. But actually this is not the answer. So you will see, like, lambda, as we are taking a mu greater than 1, so definitely the answer is let's say plus minus infinity, so definitely it will not converge, right? It will diverge, but it is not true. In that case we have to know, we like, the main thing, which is we have to choose mu so that the limit will exist. In that case we have to choose mu so that the limit will exist. And when it will happen, it will happen when we will see something like 0 by 0 or something like infinity by infinity format. Hopefully you can understand. So we have to take something so that the mu will the limit will exist. In that case, if we are taking mu greater than 1 as mu equals to 3, then it will not happen. But if we are taking mu which is, let's say, just assume, let's say I'm talking about 3 by 2, let's say, just assume it. In that case, log x to the power 2 minus 3 by 2, which is basically 1 by 3. Now it is basically infinity by infinity format, and this is 1 by x if we are using LH rule. This is 1/3 x to the power 1/3 minus, which is 2 by 3. Now if we will put any kind of, let's say, this is basically 1 by x root x, x will be cancelled out. This is 1 by basically 3 root x. So you can see here the answer is tending to 0. Now I am repeating the full process again in the next page for a proper explanation, because it is too much complicated to understand this portion. That's why I am taking this example. It's too much complicated. So let's move on to the next page for understanding this question properly. So as I have told you, like, you have to choose mu so that the limit will exist. So it depends on the question. Let's say in that question it is log x by x square into x to the power mu, and if we want to see the limit will exist, then we have to make a format something like 0 by 0 or infinity by 0. Sorry, infinity by infinity. Now the denominator is infinity, and this is also infinity, but we don't know about the x to the power mu, sorry. So in that case, what you can do, we can't take mu equals to 1, we can't take mu less than 1, we have to take mu greater than 1. But, like, if mu is 3, then it will be like infinity. So this is not the answer, right? So how in that case we will deal? We have to choose mu so that the limit will exist. So we have to choose mu so that the limit will exist. That means this is log x, this is x to the power 2 minus mu, limit x to the power infinity. Now wait a moment, if we are putting infinity at log x, then it will be becoming infinity. If we are putting this, then what will happen? Maybe it is infinity or may not be it is infinity. Why? Because, like, I am entering in a deep knowledge of limits. Basically x is tending to infinity, then it will be infinity, it will be 1 when, or it will be something any other thing, I don't know. Infinity when, if it is 1, if it is 1, that means 2 minus mu is equals to 0 and mu is equals to 2. So x to the power 2 minus 2, which is x to the power 0, which is 1. But we need a infinity at the denominator. So definitely we need a infinity at the denominator. And the third case is basically 0. Why? Like let's say 2 minus mu, x to the power 2 minus mu is 0. When it will happen? When 2 minus mu, when basically mu it is greater than, sorry, less than 0. When it is less than 0, because let's say we are talking about x to the power minus 1 and we are putting infinity, so 1 by x, which is 0. Hopefully you can understand 1 by infinity is 0. So in that case x tends to infinity and this will be becoming infinity 1 or 0. We had talked about 1, we had talked about 0, but we need infinity. And when it will infinity? When 2 minus mu is greater than 0, then it will infinity. So mu greater than, sorry for a mistake, 2 greater than mu. So we have to take mu which is greater than 1 but which is also less than 2. So the thing is like 1 less than mu less than 2. This is the formula. Now I know it is too much complicated for understanding, but what you can do, this is the let's say like this is the process of mu test, which is too much hard. If you want to understand what is mu, you need to know about some processes. Like in that case, the main approach is this, and the main approach is too much complicated. You have to choose mu so that the limit will exist, and for existing the limit we have to make this two formats. In that case we can see the upper thing is infinity. We can say something like that, x to the power 2 minus mu. Now the upper limit is the upper portion is infinity and we have to make the lower portion infinity. Now the lower portion will be infinity when this will happen. Otherwise in these two cases it will be 1 and it will be 0. Hopefully you can understand. And for making it infinity we have to choose mu which is less than 1, which is greater than 1 but which is less than 2. So let's say we are talking about 1.9 which is less than 2. So this is log x, this is x to the power 2 minus 1.9. let's say we are taking mu equals to 1.9, just assume it, which is less than 2 and greater than 1. Down this is limit, this is x is tending to infinity. Now this is nothing but log x, this is x to the power 0.1, 0.1. well, fine, limit x is infinity. Now you can see we are using LH rule, simple. This is 1 by x, this is 0.1 into x to the power 0.1 minus 1. Now if we are putting 0 here, then it will be 0. And if we are putting and if we are like using normal algebra, then we will see like this is a limit, x is tending to infinity, 1 by 0.1 into x to the power 0.1 minus 1 plus 1, right? Normal algebra. Now this will be cancelled out. This is 10 by x to the power 0.1, limit x is tending to infinity, and if we are putting x equals to infinity, then it will be like 10 by infinity, which is 0, and lambda is 0, which is not equals to plus minus infinity. So this is the approach. Now let's talk about another question so that you can relate with the process, which is very hard. Now in that case we are talking about e to the power minus x square from 0 to infinity. The answer of this integration is nothing but root over pi by 2 or you can say gamma half by 2. Okay, now you don't need to know about the answer, I mean don't need to aware about the answer, you should aware about the mu test. In that case we can see there is an exponential function, so like limit x is tending to infinity x mu e to the power minus x square. Now we have to take mu, now basically we have to take mu so that the limit will exist. In that case we can see x is tending to infinity, this is x to the power mu, this is e to the power x square. Now we have to take mu which is greater than 1, and we have to take mu for which the limit will exist, right? In that case you can see if we are putting infinity at the denominator it will become infinity, if we are putting infinity at the numerator then maybe it is infinity, maybe it is I don't know, let's see what will happen. X to the power infinity, I mean x to the power mu will be infinity, will be 1, and will be 0 and will be 1. When will be infinity? When mu is greater than 0, when mu is equals to 0, and when mu is mu is less than 0 and mu is equals to 0. This is the conditions, I mean these are the conditions. So you can see mu greater than 0, and we are talking about mu greater than 0, we have to have infinity at the numerator, so you have to choose this condition. So you can take anything which is more than 0, but also there is another condition which is mu should be greater than 1. Now we can take any value which is greater than 1, also greater than 0 definitely. This will not happen because we have to let's say like we have to choose mu as the limit will exist. So you have to make the format something like 0 infinity by infinity or 0 by 0. So in that case we are talking about infinity by infinity. In the next portion I will talk about 0 by 0 also. So first of all we can take any kind of value, like let's say we are talking about 5, mu equals to 5, let's say mu is 5 what I'm saying, mu is 5, x to the power 5 by e to the power x square, and limit x is tending to infinity. Now this is 5x to the power I'm using the LH rule. Okay, I'm using the LH rule. Now this is 5 by 2, limit x is tending to infinity x cube by e to the power x square. Now again LH rule, 5 by 2, limit x is tending to infinity. This is 3 into x whole to the power 2. This is e to the power x square into x, specifically 2x. This is basically 3 into 5, 15. X square by e to the power x square x, you can say this. So this is 15 by 4, limit x is tending to infinity. Again we are using LH rule, this will be 1, this will be e to the power x square into 2x. Now if we are putting x equals to infinity, this is 1 by infinity which is 0. So 15 by 4 into 0 which is 0. So you can say lambda is equals to 0 which is not equals to plus minus infinity. So the integration you can say will converge. Hopefully you can understand the process. Now this is all about mu test, and if we will practice multiple questions over mu test then we will understand the concept properly. Just remember it, if we are talking about any kind of polynomial then you just have to do simple thing, the highest power of the of x at the denominator, hopefully you can understand, denominator minus highest power of x at numerator. Okay, this is mu, this is for polynomial by polynomial. And what about the mix of function, like exponential or any kind of mix up of any kind of functions? In that case we have to deal with this, we have to deal with this process. Like we have to use mu where let's say the limit will exist. First of all, if we are talking about, well, I had talked about infinity by infinity. If we are talking about 0 by 0, in that case we have to make this like that. X is tending to infinity. This is e to the power minus x square into x over mu, and we are taking x over mu at the denominator, which is x over minus mu. Hopefully it is visible. Now we have to make it 0 by 0, and the upper portion is 0 because e to the power minus infinity is 0, right? E to the power minus infinity is 0. Now I have to make this also 0. When it will be 0? Let's say x to the power minus mu is there. When it will be 0? It will be basically infinity. It will be basically 0. It will be basically 1. When it will be 1? When mu is equals to 0, it will be 1. X to the power minus 0, which is 1, right? When it will be infinity? It will be infinity when mu is less than 0. Because if let's say mu is minus 1, so minus 1 and there is a minus also, so this will be x, and if you are putting x equals to infinity, then it will be becoming infinity. So when mu will be less than 0, then it is infinity. And when mu greater than 0, when mu is greater than 0, in that case, let's say mu is 2. So x to the power minus 2, when we are putting x equals to infinity, that will be becoming 1 by infinity, which is 0. So this is the condition. In that case, we have to choose mu greater than 0 again and again. I want to say, in the previous, we have to choose mu greater than 0 for making the numerator infinity. In that case, we have to choose again mu greater than 0 for making the denominator 0. So you can see here we have to choose the same value for mu for doesn't matter whatever the condition is. So this is the process. Hopefully you can't understand definitely, because using a simple or single video you can't understand. You have to practice multiple questions on mu test so that you can relate with the questions. I just want to tell you the approach, and this is the approach, and too much complicated mu test is. So be careful about mu test. It is too much complicated. And this is all about this video. And in the next video, I will try to cover the examples on comparison test, which is also important, but the most critical test is mu test, because people will stuck at a point because they can't find mu. What is mu? I have told you the approaches so that you can find out the value of mu. Using the second approach, where we have to deal with this, like we have to choose mu so that the limit will exist. In that case, we can say we can choose any value of mu. It depends on the condition. Like in the previous case, we had talked about this condition. So it depends on the question. You have to make the question, you have to understand the question so that you can understand what value should you choose for mu. In the next video, I will talk about the comparison test, which is also important. And that's all for this video. Thank you for watching my videos. And if you will understand the critical concept of comparison, improper integral, which is called mu test, then very good. If you can't understand, then comment. I will definitely reply you, or you can DM me also in my WhatsApp number. Those who have my WhatsApp number, they can DM me also. And if you have any kind of problem about mu test, then also DM me. I will definitely help you. I will try to help you basically. And that's all for this video. Thank you. Goodbye. Subscribe if you want, comment if you want, and like if you want. Goodbye. Thank you.